Base 3.6 and 3.7, we are actually going to be going into chapter 6, which deals with linear programming. And so solving systems of equations is going to be very important for you. So a system of equations is basically, you know, two or more equations, and we are, I guess, looking for their intersection. So the idea is right now most of our graphs will be two-dimensional. There will be an x and a y that we can draw on a plane, so on a piece of paper. When you get into three equations, you're talking about three-dimensional space. And so now it'd be like, you know, picture a box and putting strings or sticks that go all the way through a box, and you know, so now there's an up and a down and a depth. So that's why I say two or more equations. So in this first example, this would be set up for substitution. And so what I'm going to do is, because one of the variables is already by itself, is I'm going to take this 15 plus 8x and substitute it into the second equation. So I'm going to bring it in and put it right there for that y value. So it's going to look like negative 10x minus 5. Now instead of writing y, that's where I'm going to write the 15 plus 8x equals negative 30. So again, this is a substitution method. Eventually, you guys will pick the method that, you know, you're best at using. So
Didn't we learn this?
you probably have done this before, yes.
No, like
No. Negative 5 times 15 is negative 75. Negative 5 times 8 is negative 40. And so after the substitution, I'm doing my distribution. Now I'm going to look for like terms. I have a negative 10x and a negative 40x for negative 50x. I'm going to send the negative 75 to this side, and we add it, right? So I add 75, and I'm getting 45. Now when I divide by negative 50 on both sides, my x is equal to, you know, if you divide both of those by 5, looks like negative 9/10, right? Whenever you solve a system, you are not solving for one variable. You guys are so used to taking an equation and solving for x and moving on. But in a system, you're solving for a location, right? The intersection, it's a location. Where is it? So when you get done, you want to take that x value that you found and plug it back into one of the originals. I would go back to this one, and so that's y equals 15 plus 8 times 9/10.
Wasn't it negative 9/10?
Negative 9/10. Thank
So
you.
are you making a y equals equation?
So 15, what was it? 15
plus 8.
plus 8 times negative 9/10. 7.8. So my answer then is this x and y. You want to write both of them down. If you want to use negative 0.9, that's totally fine. Either one. But the assumption kind of here is don't assume that it's always going to be 3 and 5. Nice whole numbers or nice integers. You may run into some decimal. Okay? Okay. So the next example, I want to move to number 3. So like I said, I just want to create a video with a couple examples of what different techniques you can use. In the next one, there are several techniques that you guys might try with this, and one of them, the algebraic technique, some students or some teachers call it linear combination, in other words, combining two linear equations, and some will call it elimination. So one of the reasons why they would call it elimination is because when I go to, if I just look at these two equations, and basically in this case, if I add them together, what's going to happen? I get 7x. The y's are gone, right? Negative 2y plus 2y is gone. And I'm left with 21. Divide by 7, and my x is 3. So right there is an example of why they call it linear combination. I just combined two linears. That's where it gets its name. Or I eliminated the y variable, and that's where it also gets its name. They're the same technique. So once your x is 3, you would plug it back in to either equation. It doesn't matter. Just go back to one of the originals. I'll just do the bottom one. So that's 4 times 3 plus 2y is equal to 4. So I'm putting the 3 back in for the x. So this is 12. So I'm going to subtract 12 on both sides. I get negative 8. Divide by 2, and I get y is negative 4. So there would be two solutions, or the point of intersection. So they're not always set up perfectly, where you can just add them together. So what would you have to do, even though the next one you could subtract? I know you can subtract, but what would you have to do to the next equation to eliminate the y's again? You would have to multiply the top by 3, and maybe you would now again, this is where I think for students it gets confusing. Some teachers teach you to get the number to be the same and subtract. I teach you guys get them to be the same and then add them, because if you go into subtraction, it gets to be opportunities for mistakes. So what I'm going to ask you to do then is, if you're multiplying the top, I want to multiply the top not by 3, sorry. Multiply the top by 4, and let's multiply the bottom by negative 3.
Wait, where did you get those numbers?
Hang on just a second. So, I'm picking 4 and negative 3 because I was asking a question, how are you going to get rid of the y's in this case? It'd be really easy to say subtract and just say 2x minus 2x would be gone, and then negative 3y minus a negative 4y. But it's a little bit more difficult to keep track of negative signs. So by multiplying everything on top by 4 and everything on the bottom by negative 3, what do you notice about the y values? So when you go to, I guess, what I call squish them together, like if you go to add them together, those will eliminate themselves. And what's 8x minus 6x? 2x. Negative 20 plus 12. Negative 8. Divide by 2. And I get x is negative 4. Take that, plug it back into the original. And we're going to have 2. Let's go to the top one. 2 times negative 4 minus 3y is negative 5. This is negative 8, so if I add 8 to both sides, I get negative 3y is equal to 3, divide by negative 3. Y is negative 1. So those would be your two answers. So yes, on the very last problem, I did not necessarily do it the easiest way. I was just showing a technique. I prefer to get the numbers opposite sign, one positive, one negative, to eliminate them. The last technique that I'm going to show you, is using your calculator. It's called the matrix technique. Now, to use the matrix technique, you would have your, oh, maybe I'll end up showing you one more, but no, probably not. The other one would be to do the matrix. So we want to put matrix A is 4, -2, 8, and 6. And matrix B will be -2 and 31. So what we call matrix A is what's called the coefficient matrix. It's the numbers in front of your x's and y's. Now, when you do that, be careful that your equations, right, are x, y, equal to the constant. It needs to be in this form. Now, if you look at the other examples that we've done, a few of them have been in this form, and a few of them have like just the y, in which case you can bring the x over and just put it in the proper position. So, let's go into the calculator. My matrix button is right above the x to the -1 button, this inverse button, so 1, 2, fourth one down. So I'm going to enter the second. So I'm entering into the matrix mode. Now my calculator has stored a few different matrices. So when you want to work with matrix A, you want to slide over to edit. Which matrix do you want to edit? I want to edit matrix A. This is where I'm going to put my coefficients. So this is a 2 by 2 matrix. Rows by columns. Okay? 2 rows by 2 columns. So put 2 by 2 and then enter those numbers carefully. 4, -2, 8, 6. Then you want to go back to matrix and you want to edit matrix B. Now when you look at matrix B, there are 2 rows again, but only 1 column. So this is a 2 by 1 matrix. And the first solution is -2, and the second solution is 31. So I entered 4, -2, 8, 6, -2, and 31. Okay? Once you have the matrices entered, your work is really done. What you're going to do is tell the calculator to do the inverse of matrix A times matrix B, and it will spit out your answer for you. So we're going to go back to matrix. I have to grab matrix A. So you hit enter on matrix A. So it puts that matrix on the calculator screen. Hit your -1 button here, the x to the -1, the inverse button. That takes you all of, 1/3 of a nanosecond. That would take me probably a week to teach you guys how to do that. It's row reduction, and there's a lot of mathematics that goes on behind it. But you guys are letting the calculator do the work for you. Now you go back and you grab matrix B. So you have A inverse B sitting there, and you hit enter. What are your answers? 1.25, 3.5.
Okay. How did you do a little -1 thing up there?
So your x is the first one, and your y is the second one. Right there, that fourth one down is the x inverse button.
Oh. And then you times the B. Is it?
To see how fast this works, let's go. Let's go back to a problem that we've already done. Now, let's just go back to the very first problem. Shh. The very first problem. What I want you to do is take this top equation, and I want the 8x to come over to the left. So it's going to be negative 8x plus y is equal to 15. Now look at all the work we did in number 1. By bringing the negative, or the 8x, excuse me, over as a negative 8x, we're going to type those numbers in. So go to your calculator. We're going to type in matrix. So we got to edit matrix A, keep it a 2 by 2, and we're going to go negative 8, 1, because that's a 1 in front of the y, negative 10, negative 5. Go to make, because I brought it from the right-hand side to the left-hand side. Then you edit. Matrix B, this is the solution part, and we had 15 and negative 30. Now if you're doing a bunch of these in a row, all you have to do is hit second enter, and it pops the A inverse B on the screen again, and you hit enter, and there's our negative 0.9 and 7.8. We're going to do one more technique, and I'm going to do it with number 5 here that we've already got the solution to. It's also on the calculator, and it's the intersection mode. But to do the intersection mode, I need to take this equation right here. It's negative 2 over there. So I'm going to bring the 4x to that side, so it's negative 2 minus 4x. So if I take that 4x to the other side, I'm going to put that in parentheses because what's in front of y? At the end, when you solve this, you're going to end up dividing by negative 2. And the second equation, you do the same thing. How do you get y by itself? You must take the x term to the other side and then divide by what's in front of y. So it ends up being, this is like y2 if you will, 31 minus 8x divided by 6. So when you go to your calculator, we have parentheses, negative 2 minus 4x divided by negative 2. So that's the first equation. Then I have parentheses 31 minus 8x divided by 6. And if you look at a graph, that's the graph, and then you go second trace, which is to calculate, number 4, the intersection, and then, second trace, intersection is number 5, excuse me, and then it's sitting there saying, what's your first curve, what's your second curve, and guess. Well, you only have 2 equations on there, so you can just hit enter, 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 and you get 1.25, comma 3.5. Which is the same thing we got right there.